To start again with the percent resistant by region for 2011, we'll take a look at assessing for unequal variability, as well as for how to test for unequal variability, as well as the test to report if you decide you don't want to assume unequal variance. So beginning with the fit y by x, region is your x, 2011 is your y. You get your ANOVA figure. You can take a look at your means and standard deviations. If the number of observations in each group is identical, so you have a completely balanced design, it is important to know that the equal variance f-test and the unequal variance f-test will give identical results. If you have a balanced design, you shouldn't have to worry about equality of variances. Nonetheless, you can always test for it and always account for it using an unequal variance f-test. If you have imbalanced n's per group, more than 1.5 times as large, so for a 7, you would be looking at 14 would be 1 time as large. So if you're looking at 2 times as large, 1.5 times 7, we're sort of borderline with the 10, but we're definitely looking at a larger southern group than we are for the northeast and west. So you may be concerned just based on that. You can also look at the standard deviations. Now the west group has a very large standard deviation due solely to this outlier, which is from the state in row 45. You can actually hop back into your data set and see that's from Nevada, reported an unusually high value, though it is important to note that if you look under 2011 overall, that it is not the only value that high. There are 3 values that are 70 or higher in the data set, so you should not automatically assume that that data point is erroneous or is an outlier. It just happens to be an outlier for that region. You can see that there are points right here in the southern group as well. So while you may verify it, that may change your variability. Recall that you also have a lower outlier here in Montana. It is by all accounts the lowest at 27.3, though there is a value here in Iowa that is also quite low. So after you've done your distributions, looking overall and then by group, you can go ahead and look at the normal quantile plot actual by quantile. First, we're looking to assume normality. So that would be dots along the line for each group. And then if the lines are parallel, that would indicate equal standard deviation. We have somewhat parallelism between the blue line, which is the south line of a variance of 9.2, and the red and orange lines that are kind of on top of each other here. And those are actually the Midwest and Northeast, so 9.2 and 4.3. Those sort of look okay. Or excuse me, that's the 9.1 and the 13.4 are the bottom 2 lines. This green line here, this one right here, that is for the Northeast group. That is for this group here. And that is for a variance of 4.3. So that is really probably our largest concern in terms of violating the assumption of equal variance. These lines, it's not parallel with the blue line, and in fact, it's crossing over the orange and red lines. That should give us some concern. If we would like to test for equal variance, that is an option, unequal variances. And you can see here that we get our test statistics. Now remember, we look at the Brown-Forsyth test. It is more robust to departures or outliers, departures from normality, so we'll take the Brown-Forsyth test. Our null hypothesis is that the variances are equal. Our alternative hypothesis is that they are not equal. This p-value is large. It is telling us that we fail to reject the null hypothesis of equal variance, and we could then go ahead and proceed with the equal variance ANOVA. If this test rejects, or you have imbalanced sample sizes, or you simply don't want to assume equal variances, you can report then the Welsh ANOVA. Again, it tells you, JUMP tells you here, it's testing means equal, allowing standard deviations to not be equal. Notice our degrees of freedom here in the denominator have a decimal place. That's because it's weighting or allowing these different variabilities and these different group sizes to be accounted for. If you report the Welsh ANOVA, you can simply report the p-value and say that you did a Welsh ANOVA, or you can report the F with 3 and 16.7 degrees of freedom. That decimal place in the degrees of freedom will indicate it's an unequal variance test. Do not round your denominator degrees of freedom to a single integer value. That would imply an equal variance test. You will report Welsh ANOVA, p-value 0.0005, indicating that there is a statistically significant group difference for 2011 results by region. Up next, we'll look at how to report or how to test if we don't want to assume normality at all, and that will be the Wilcoxon test.